Moondust rocket thruster. This is our team photo. Patrick, Nick, and Sam are our mechanical engineers, Espen and Grant are our electrical engineers, and Andy is the computer engineer. We are trying to make space travel cheaper. By using a propellant readily found on the moon, our system has the potential to be millions of dollars cheaper than the current designs for propulsion systems used in lunar missions. Our vision for the end state of the project is a working prototype to demonstrate our concept's feasibility in the field, much like how the first plane was simple but evolved into the SR-71. We do not expect a perfect prototype. However, we expect to show that our proof of concept can be expanded upon to create a new generation of rocket thrusters. Our approach is to ionize moondust and then use an electric field to accelerate it.
The image being shown is the full device, just minus the moondust propellant. Obviously, we cannot obtain actual moondust for a project, so we created a mixture that closely resembles the chemical composition of moondust. This mixture is loaded into the 3D resin printed funnel that acts as our mass flow control device, which is this component right here. The device falls out of the custom funnel directly in front of our ionizing device that is comprised of charged plates and glass for insulation, which are these parts out here, out of that. The device adds charge to or ionizes the dust and is required to be operated within a vacuum chamber to achieve the highest possible ionization. And the outside device here is the vacuum chamber. The charged dust then falls into an electric field, which is produced by two parallel plates, two plates right here. Field is down in there. The plates are charged to a very high voltage. The field will accelerate the dust to supersonic speeds and then produce the thrust of 1 pound in a specific impulse of 200 seconds. When the ionized dust is accelerated to supersonic speeds, the equal and opposite force propels the spacecraft forward. The device must be in a high vacuum to prevent arcing between the parallel plates of both the main device and the ionizing device.
To measure the high voltages, we used a voltage divider circuit similar to the one shown here. To verify that we are actually charging the moondust, we created a Coulomb counter to measure the charge on the dust, similar to the one shown here. Our largest challenge was our switch from using this device in an argon chamber to a vacuum chamber. We definitely learned more about rocket science than we expected. We would like to thank everyone that helped us.